because they don't have that 32 or something. Let me see if I can come up with a good example. Square root of xy. That's gross. So if I said x, let's say, if I said y is t, so I get t cubed x equals square root of xy. You made this difficult on yourself. So if I let's see which way I want to go. Stay with me now. Oh, y equals t, sorry. So there's a t there. So this doesn't sound familiar to anybody?
No.
Just a few of you guys.
No.
So if I try to solve for x, I can actually divide this side by square root of x. So I get t cubed x to the 1/2. Because this is what x divided by square root of x is. Is that cool? 1 minus 1/2. I'll get x equals t to the 1/2 divided by t cubed is t to the negative, I can't even think, 5/2, right? Squared. So I get x equals, that's some freaky shit, really. That's weird.
Is that 5 on 2, right? Negative 5 on 2?
Yeah, I think so. 1/2 minus 3 divided by the t cubed. But the point is, you can plug in here, I don't know why I'm trying to make a problem that actually works, because you could just put in here like sine of t and cosine of t. And when you graph it, you get a little circle. And if you put in there stuff like sine of 5t, you get funkier shapes, right? In fact, I got to zoom in a little bit. That's neat shit. I mean, that's where you get the spirograph stuff and all this stuff. Does this sound at all familiar? Just the two of the people I talk to. Because there's a whole parametric equations chapter in your pre-calculus book. All right, so what's going to save you is, this is all kind of side stuff to what I'm talking about. If you are going into, I can't remember if it's in Calc 2 or Calc 3, but it's in at least one of those. There will be a lot of parametric. It's in Calc 2. There's a lot of parametric equation stuff you have to do. You have to do calculus on parametric equations. So if you never got the basics of parametric equations, that's going to be fun. So if you are going into Calc 2, I highly recommend that you get your old pre-calc book that you never sold back because you know you're smarter than that. Or go borrow one. And then look up the section on parametric equations, get yourself familiar with it. Anyway, I know what I was trying to do here. So, now I got way off on a tangent. What was I talking about? Oh, that's one way to graph in your calculator these functions that come back on themselves, because if I define x as a function of t and y is a function of t, then I can go, my y direction is being controlled by its own function, and my x direction is being controlled by its own. It can do whatever the hell. So obviously if I define it by sine and cosine, they're going to both be kind of kept in, because sine and cosine have maximal outputs. Right? So you always get this kind of closed thing. If I define one of them in terms of a polynomial, then it could just go off. It has to go off. It has to get big outputs at some point. You guys semi with me? Very often we like cosine and sine because then I can get a complete picture without having to go from negative infinity to infinity to capture the whole thing. Okay, but enough of that. So let's see what else they're going to have us do in here. Here's a weird one. look at this one. If g of x plus so very often the problems that are most hated are the ones that have f of x and g of x inside of the equations. You got to do something with them. But that really is just like y here, right? With the implicit stuff we were doing before. This is a function of x that I don't know what it is. By the way, it didn't say sing, right? Okay. So if this is true, find g prime is 0. So I got to first find g prime of x. Now hopefully you guys, I haven't said this yet, but as one person came to my office and we talked a little bit about this, you never plug the value in before you take the derivative. Because of course what happens when you plug a value in, you have a number, and the derivative will always be 0. So you're not going to find it anything. This says, what's the slope at 0? The slope should be changing all the time. It can't be eternally 0. Right? So don't plug the number in before you've done the derivative. It doesn't make any sense. I can't plug a number in until I know what the function is I'm using. And the function I want to use is g prime. I don't know what it is yet. How can I plug a 0 in? Okay, so how do I find g prime? Do you guys like it better if it looks like this? Because that's all I'm doing, right? You guys with me? Yeah. How do I find y prime? Just replace g of x with y, if it looks better. Alright, so derivative of y is y prime plus, what do I have to use here? Product rule. X prime is 1 times sine y plus x times, what's the derivative of sine y? Cosine y times y prime. Right? The minute you take the derivative of a function with y in it, you will have to have a y prime there. This chain rule. Yep. Just make it really clear that's outside of there, right? Where are we at? Equals 2x. Whatever you do, one side guy to the other side, right? So this product rule was x prime sine y, so that's sine y, because x prime is 1. Plus x derivative of sine y. When you do that guy's derivative, the inside has to get a term. You can see how easy it is to forget some y prime somewhere. Right? Now how do I get y prime by itself? Get rid of the sine y. Take a y prime out of 1 plus x cosine y. Alright, guys. Should be able to handle it when I do something like that. Did I get it right? Yes. So I got the sine y out of the way. Took a y prime out, so it's 1 plus x cosine y. And then just divide by the stuff I don't want. It's kind of nifty. There's always a little bit of a symmetry. Sometimes it's even more, it's very symmetric. Like you get 2y plus cosine x over 2x minus cosine y. You'll get some kind of symmetry in this implicit differentiation. It's kind of cool. So so this is really g prime of x, right? Just bring it back in. So then when they ask me what's g prime of 0, what do you get? Plug in 0. I like it. And did they give us any information? Let's see. No, they just give me that. So I'm sorry. So you get 0 minus sine y over 1. So you get negative sine, and be more specific actually. Don't forget your negative. What is y? Oh, he's probably. What is your problem?
You should upgrade
To what?
iPhone.
That's not an upgrade if I get the new software. What are you talking about? Yeah. All right, why are you not recharging? Oh, screw.
Mr. Waller, do you have a Snapchat?
There it is. I am actually kind of proud to say I have no idea what the heck you're saying.
Good job.
What's Snapchat? Don't even tell me. I have a feeling I could live without it. What is y? G of x. And actually, where am I evaluating it at? 0. So that's the best I can do because they didn't tell me what g of 0 is. So it's negative sign g of 0. I like giving that kind of problem out. I would actually tell you what g of 0 is, and you have to realize why I would tell you that. And again, it's because wherever I see y, it really should be g of x. So that's negative sign of y, so it's g of 0 there.
Would you get that negative sign by the g of 0?
Because when I plug a 0 in, I get 0 minus sine y.
Okay.
Yeah, so I'm just plugging a 0 into my function now.
Alright.
Because they want g prime of 0. Cool. Okay. Ooh.
Would you take that another step and plug the 0 back into the equation to get the g of 0? So we get negative sign of the g of 0?
Well, if you take, let me see. Back in my brain. So if you have g of 0 plus 0 times sine g of 0 equals 0 squared. So g of 0 must be 0. I love it. And then what's g prime of 0? Negative sine of 0, which is 0. Cool. So they did give me enough information to figure out what g of 0 is. I just didn't have to know it. I needed it until the end.
How did you get from 2x minus sine y, which I have g of x, over 1 plus x cosine of g of x? How did you, I'm, where you have g prime of x equals y prime, I'm with you right there. That's what I have written down right here. Now when you go down to g prime of 0, so you got the 0.
Well, 0 is what they're asking for. So I know what g prime of x is. I know what g prime of x is. Now plug a 0 in for x.
Okay.
So that's 0, that's there. 1 plus 0 is 1.
Yep.
Okay, cool. And what's y?
G of x.
G of x, cool. So that's g of 0 because I wanted that 0. Right? And then with a little help, we figured out, you can actually, from the original equation, figure out what g of 0 is.
Okay. I just automatically, I left the g up on the sign.
Which is good. Now you just got to plug that 0 in explicitly. Yeah. Okay. I'm just kind of going through each of the sections in the homework to show you. The next kind of problem they would have is. Here's a good one. I think that might be one I signed. So they say find the slope. Actually, they say even better. I like it. Find the equation of the tangent line to the curve at the given point. Have you guys ever seen that? I'm going to write an equation like that. EQ with a little n up there is understood to be equation. Sometimes you'll see f, that's understood to be function. Right, whenever you have that, they just put a little n up there. So, this should be a standard calculus problem, even for us, even though we're just in our whatever week it is of calculus. Find the equation of the tangent line and the point. We know how to do that. We know the steps. You first find the derivative, right? Then you plug in the point you're interested in, and then you use good old mx plus b or y minus y1, blah, blah, blah. right? It's very standard. They're going to keep coming back. They and me. Every test, basically, I'm going to have a question a little bit like this. Because you're going to learn more and more derivative rules and so forth. So now we've learned implicit differentiation. I can do this and I can plug that whole point in now. And this happens to be, they say in the book, what kind of a function is this? What kind of a graph? I love you guys, because they say in the book, and nobody looked down. I love that. No, it's good. That's what's supposed to happen. I would expect, everybody was expecting where we go, hyperbola. So this is hyperbola. Why do I know that? Because, yeah, the x squared minus y squared. It's not plus, that would be a circle or an ellipse if the coefficients were different.
I said ellipse.
So this would be a circle if that was a plus, since it's a minus, it's hyperbola. Okay, I like it. So how do you do the step? To find the equation of the tangent line, we first need the slope, which of course in calculus tells me to take the derivative. So how do I do that? Good. Careful. Maybe not so good. What do I have to use here? Product rule, right? So 2x prime y plus 2xy prime. You guys with me? I can even do 2 prime xy, but of course 2 prime is 0. Minus 2y minus y prime, I love it. Plus 1 equals 0. And tell you honestly, if you really wanted to, you just plug 1 in for x and 2 in for y, and solve for y prime, right? But you should be able to, obviously, you should be able to handle solving for y prime. First off, I haven't finished all my derivatives yet, so this will be 2x plus 2y plus 2xy prime minus 2yy prime plus 1 equals 0. How do I solve for y prime?
Y prime on the left, everything else on the right.
Yeah, so I'm going to actually move my y prime stuff that way, just so more stuff stays positive. It doesn't really matter. You guys with me? So leave that, and that, subtract that, add that. Take out a y prime, and I'll be left with 2y minus 2x. So I divide by that. Is that cool? So this first step was the calculus step, and then everything after that is algebra. And I can give this to my algebra students and not tell them what the hell, and just say solve for this dude, this y with a line. Solve for that. They'll do it. It's the easiest thing.
Can you show me what you did for the last step right there?
From here to here,
Yeah.
take a y prime out,
Okay.
times 2y minus 2x, and then I divide it by 2y minus 2x.
Okay.
So what's the slope at the point that I'm interested in? How do I find that? Y prime at 1, 2 is going to be 2 times 1 plus 2 times 2 plus 1 over 2 times 2 minus 2 times 1. That kind of is a nice thing about implicit differentiation. You know the whole point, you actually use the whole point. You can plug it in for y and x. So I get 2 plus 4 is 6 plus 1 is 7 over 4 minus 2, so I get 7 halves. Okay. And now I just got to find the equation of the line. Not a big deal, right? In fact, I mean, some of you guys should be able to just do this. 7 halves x. X would be 1. So far I have 7 halves. I have to put something there so I can make that become 2, right? I don't know if you guys are with me at all. I don't want to use mx plus b. I don't want to use y minus y. I don't want to be a cowboy. I want to just figure it out directly. If I plug a 1 in, so far I have y equals 7 halves. What do I want y to be? 2. So how would I make that become 2? I have 7 halves so far. 2 would be 4 halves. Make it 3 halves. I mean, get past all that mx plus b shit that you needed before. You should be able to kind of get there a little bit quicker just by adjusting it on the way. That's awesome. If you can't do that, you can still have to use mx plus b. Or y minus y1. Yeah.
How did you do that?
I forgot. Oh,
Horrible.
this line is supposed to go through 1, 2. So I know so far the slope is 7/2. If I stop there, I know I'm wrong, because when I plug a 1 in, I don't get a 2 out. So I just adjust what I do get out. When I plug a 1, I get 7/2. To make it a 2, I subtract 3/2.
Okay.
That would make it 4 over 2, which would be 2. Right? Some of you guys might never even thought about the fact that you can do that. I don't know. Anybody thought about that?
No.
Anybody understand what I'm saying?
Yeah,
Anybody think that's sort of cool a little bit?
because
It's like
if you
instead of-
subtract 3/2, you get 2.
Yeah, there you go.
Instead of plugging in the 2 for the y and the...
Yeah, and solving, you guys should be able to handle that in your head. It's really just doing the MX plus B form quicker. Yeah, I like it. Okay. So that's your equation of the tangent line of this hyperbola. So if you have this hyperbola, can anybody tell me, is it going to be this kind of thing, or is it going to be this kind of thing?
It's going to be the first one.
Probably the first one, because that's the one I actually drew, right? So I kind of
Because y equals,
because x squared is positive 1, right? Y squared is a negative 1. And I'm at the point, who knows, 1, 2, so maybe I'm here. Let's pretend like it's there. So, and now the tangent line is 7/2 x, so it's positive 7/2. That kind of makes sense, based on this graph that I completely drew arbitrarily. But that's the idea, right? You can always graph, well, you can't here really easily. Oh, that's true. I was going to say you can graph from your calculator, but you really can't. You can graph this in Wolfram Alpha and see if it makes sense. Okay. So there's that kind of problem. That's section, the numbers 25 through 32. And I like it. I mean, the cardioid should look familiar. Remember the cardioid? Right, it's either the heart graph or the butt graph, depending on which way you graph it. Asteroid, the lemniscate, the devil's curve is a new one, right? I mean, you'd be surprised how many functions have names. Number 33, the Campbell of Eudoxus. To be completely honest, I have never heard of that. I might have at some point. I don't think so. Oh, one last one. I'll let us out of here because I did promise we'd get out a little early. And you're gonna love this one. So now I want to find y double prime.
Yeah.
Yeah. I like that reaction. So I can find y prime, and once I find y prime, I just do the whole damn thing again. Right? Except now, let's see what happens. So what's the first step here to get y prime? Go in that direction.
3x squared.
Yeah, 3x squared. 3y squared,
Y prime.
y prime
0.
equals 0. So I get y prime equals,
Negative x squared on this squared.
I like it. Is that cool so far?
Oh, yeah.
And to tell you honestly, considering that the next thing I want to do is to do what I just did again, I'd rather not have
A fraction.
a fraction, exactly. Look at you knowing where I'm going. So I'm actually going to pull that y squared back up here. Now see if we can handle this. Right? It doesn't really matter. You could do that and just use quotient rule. I still just have this internal bias against quotient. I never used it when I was learning this stuff. It's still useful. So how do I then do the next derivative? Anywhere I see y prime, its derivative, of course, is going to be y double prime. But anywhere I see y, I still have to tack another y prime on. Right? Still the same idea. So to do this guy's derivative, I mean the derivative of this, which is y double prime, times this, plus y prime times the derivative of this, which is 2y y prime. You with me?
Yeah.
So I did that guy's derivative, left him alone, plus left this guy alone. The derivative of y squared is 2y y prime. 2y y prime.
Okay.
Equals, yeah, negative 2x. I like it. The only thing you can really do is I know what y prime is. So wherever I see y prime, I put negative x squared over y squared. Right? So I want an expression for y double prime in terms of only x and y. I want to be able to figure out y double prime at any point, just like I can figure out y prime at any point. I don't want to have to first figure out y prime, and then, I already know what y prime is. So this will be y double prime. Actually, let's first solve for y double prime before I get all this other crap running around. Now stay with me. The only y double prime is here. So I'm going to pull that stuff over. Trust me, keep it like that so it doesn't get all freaky. As if it's not already. Is that cool, just solving for y double prime? Subtract that over, divide by y squared.
Would you get that y squared right there right next to the y double prime right there?
Because it's there. So I'm using the product rule. Drew the first guy, leave this guy alone, plus leave this guy alone, drew the second guy. Right? Product rule. Okay. So now wherever I see y prime, yeah, it's this, and I see two of them, so it's actually going to be this squared, so it's going to be x to the fourth over y to the fourth. And then the only thing you really do to clean that up is to do what? What's the only thing that really needs a little cleaning up?
X fourth y.
Yeah, I can multiply everything by y4. So there's no fraction inside of a fraction. But you guys see that last step I just did? I have y prime, so it'll be two of these. So x4 over y4. And then I can multiply by y4. It's actually a good one for symmetry. Multiply top and bottom by y4. So you get negative 2x y4 minus 2y x4 over y6. It's kind of nice. That's plenty. I said we get out early. I'll stick to it. So we got up through 3.5. Oh, before we get too far away. Quiz. No, not next Wednesday. Next Monday. 3.13. I won't put this stuff on it yet. I'll just go up to 3.4. So you have to know all your trig derivatives memorized. There's 6 basic trig derivatives must be memorized for that quiz.
Test.